Hey, welcome back to our video series on, top Facebook questions on LeetCode. We're going to go through this, every question in the series. Hopefully, we'll get through as many as possible before an upcoming interview. And I'm just going to basically tell you about what's happening, what I'm thinking about, and we'll move forward from there. So last episode, we talked about longest common prefix and the ThreeSum. Today we're going to be tackling 16 and 17, ThreeSum Closest, which is very similar to our ThreeSum problem we did yesterday, and our letter combinations of a phone number, which is a classic backtracking question that we'll target or tackle. Yeah, so hopefully it'll be pretty easy, but we'll see how it goes. We're going to start off with our ThreeSum Closest. All right. So here we go. Given an integer array nums of length n and an integer target, find three integers of nums such that the sum is closest to target. Return the sum of the three integers. So we're not returning the difference, we're returning the sum, and we're not returning the three integers, we're returning the sum. You may assume that each input would have exactly one solution. So we don't need to check for the possibility that there are more than one solution. So basically what we'll do is, just go through and see what's going on. So here we go. Input nums equals blah, 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 blah. So basically it's a very straightforward question. It's very similar to ThreeSum. It's a bit different because instead of trying to get 0, we are trying to get as close to the target as possible. So we're going to take a very similar approach. We're going to sort our nums array and then go through and try and get as close to the target as possible. So let's go ahead and do that. So here we go. We'll say const sorted nums equals nums that sort of a comma b, where a minus b. Okay, so that will be our classic sorting. So what will our new, we'll just use this one here. So we'll go, we're now at -4, -1, 1, and 2. And of course our target is 1. So our new sorted array is this one here. So I took this one here minus -1, 2, 1, and -4, and I ran the sorted method on it, and we got this. And then similar to what we did last time, we're going to use a 2-pointer where we will initialize a current pointer, and then we will also have a left. What is this? Sorry about that. We'll have a left, and then we'll also have a right pointer. And then what we want to do is get our sum, see how it compares to the previous closest value. We'll set it at infinity because that is the largest number away from our target. And we'll say if this target minus this sum, the absolute value of that, is less than the target minus infinity, the absolute value of that, then what we want to do is update our closest number to this sum here. So it's very similar to our previous one. We're just keeping track of a different, output. So let's go ahead and get started. So we'll say for let I equals 0, I is less than our nums dot length. I is incremented every time. If we want to get crazy, we can say -2, I guess, because we don't need to check the last 2 elements, because that would just be, that you would not be able to get 3 elements, but we don't need to do that. Our logic would automatically remove a case like that, but just in case we want to save a little bit of time, wouldn't be that big of a deal. What we're going to do is implement a left pointer. So let left equal, what are we saying? It is I plus 1. All right, that's our left pointer. Right here, this is I plus 1. So, and then we also want to implement our right pointer. Let right equal, what are we doing? sorted nums dot length minus 1. Might as well update this as well, actually. Sorted nums dot length minus 2. Yeah, pretty straightforward. So we have our left and a right pointer. And then what we want to do is say while, we're doing a while loop, left is less than our right. So remember, we're just trying to get as close to this target as possible. So if this target is less than, or if this sum here is less than the target, we move our left because we're getting rid of the lower numbers and adding in a larger number. If it is larger than our target, we'll reduce the value by removing a larger number and adding a smaller number to it. So while our left is less than our right, because we cannot use a duplicate number, what we want to do is we'll get our first sum. So constant cur sum is equal to our sorted numbers at I plus sorted numbers at left plus sorted numbers at right. So that will get us the sum of -1 plus -4 plus -1, -5, plus 2, which would be -3. And then what we want to do is also make sure that we initialize our current closest. So we'll say let closest equal, and I said before we're going to start with infinity because that is the infinity. That is a value that is the furthest away from our target, no matter what. So we'll do that. And then, let's see, so we have our current sum, and then we need to see if we have to update our closest. So if our math.abs absolute value of target minus our cur sum is less than, so we're seeing if it is closer, then math.abs of target minus our current closest. So if this cur sum is closer than the current closest value, what we want to do is update closest. So closest is now equal to our cur sum. So we do that, and then we need to check if we need to move our left or our right. So if our cur sum is less than our target, that means it is too small. We need to remove a small value and add a larger value. We want to move our left pointer. Left is incremented. Else, what we want to do is decrement our right. So we have our left here, and we have our right here. And then that will move it along. And then at the end, what we want to do is return our closest value. That should be this one up there. Okay. Let's see. Something is wrong. Let's see. What is wrong here? I'm missing something. Okay. While loop. Whoops. There we go. Got to close your brackets. So we'll do that. So we'll run through it. Basically, we'll say -4, -1, and 2. That is a value of -3. The difference between our target 1 and that would be 4 versus our target minus the absolute value of target minus infinity. That would be infinity. So 4 is in fact less than infinity. So we update our closest to be a -3. And then our -3 is less than our target. So we move this up. So here we get a -1. Again, we check if our -1, 1 minus -1 is 2 versus 1 minus -3 is 4. Yes, 2 is less than 4. So up here, again, we update our closest to -1. And then we start over because left would now be not less than right. So what we want to do is move this one up. Our current is now -1 plus 1 is 0 plus 2 is 2. Let's see, blah, 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 blah. Target minus -1, that is 2. So that this value here would be 2 versus 1 minus 2, absolute value, that would be 1. So 1 is in fact less than 2. So we update our current sum to our 2. And then we break out and we return it. So yeah, pretty straightforward. I'm going to go ahead and run it just to show you that it works. It should work. I hope it works. I haven't tested it, but let's go ahead. Let's run it. Come on, give me some green. There we go. All right. Let's get rid of this. You don't need it anymore. And we're going to go ahead and submit it. Let's see if it works. Against a large test suite. Okay, very good. We are middle of the pack for runtime. Expected. In our memory, not so good. Probably because we create a new sorted, but that's what I want to do. Anyways, we're going to move on to our next question. So, just to be clear, so this is an in-login method, and then this is, I guess, in squared. So our total time here would be in squared, which is better than in cubed, but let's go ahead and move on to our next one. So this situation here, we have letter combinations of a phone number given a string containing digits of 2 to 9 inclusive. So we do not include 1. There's no letters associated with that. And we do not include 0. That's a space. We do not include that. Maybe you knew people have never used this, but back in the day, I could text in my pocket using these. It was pretty cool. T9, baby. T9. Return all possible letter combinations that a number could represent. Return the answer in any order. A mapping of digits to letters is given below. Note that 1 does not have a map. Okay, that is a big hint right there. A mapping of digits. So that is telling us we need to create our own object. So we're going to go ahead and do that. We'll say const, we'll say conversions, and we're going to create an object. So first up, we have our 2, which has a value of A, B, C. Next up, we have a 3, which has a value of D, E, F. 4 has a value of G, H, I. 5 has a value of J, K, L. 6 has a value of M and O. Let me check my calendar. Hopefully I don't have any interviews coming up. Nope. Okay. 6 has M and O. 7 has a value of P, Q, R, S. 8 has a value of T, U, V. And 9 has a value of W, X, Y, and Z. So that's a big hint there. When it says you have a map, what you want to do is create some sort of conversion object, mapping the key to the value it is associated with. Next up, all possible letter combinations. So this is a classic, I guess, backtracking question. Whenever you see you need to create all possible letter combinations, it's going to be a backtracking question. So we're going to go ahead and implement it like that. So first up, we're going to have our output let output, and that is going to be, we're returning this here, an empty array. And of course, if our digits.length is less than 1, what we want to do is return an empty array because there's no digits to return. So our output here is there, and then we're going to also have a stack. So let our stack equal this bad boy. Classic stack question. And then what we want to do is go through and implement sort of a recursion. So whenever I implement recursion, I call it a helper. That's just how I was told to do it. And our helper, we're going to be passing in an index. The index will keep track of which number we are on. So here our index will be at 0, and then it will increase to 1. And then if our index is greater than the length of our digits, we will return. So our helper will keep track of our index, and we'll start it out at 0. Pretty cool. So our helper, and then let's see, what we want to do at the end is return our output. And before we do that, this is something that has always tricked me up. I need to call our helper. There's been so many times in my young career where I forget to call the actual helper, and then when I return output, it's just an empty array. So first up, what we want to do is, if our index is if our index is greater than or equal to our digits.length, what we want to do is we'll push what is on our stack. So we'll get there in a second. I'll leave that in a second. So basically, when we get to the end of our digits, what we want to do is push whatever value on our stack is into the output. So we'll say output dot push, and then what are we pushing? We're pushing our stack. Our stack is an array, so we need to join the elements into a string because we are asked to return a string. And then at the end, what we do is return. So basically, we're going to implement a for loop. So not a for loop. Well, yeah, I guess it would be a for loop. For, let's see. Constant cur num equals, we'll get digits at I. So this is just to keep track of the number we're currently on. And then here, we know that we can look up our conversion here. So we say for const character of, and then we'll get conversions of our current number. So this will return this here. We'll look up our number. So we'll start at this 2 here. We'll come here. This 2 is equal to ABC. So we'll get each character of A, B, C. So we'll start out with A, then we'll move on to B, then we'll move on to C. What we want to do is say stack dot push. So we're adding our character to the stack. So this new stack will be have a value of A, and no, 2, yeah, A at first. And then what we want to do is call our helper again. So here we'll go helper, and then here we'll say index plus 1. So then our new index is 1. It is not greater than or equal to the length of 2, so we move down here. The current number is now the second number in the number at index 1 of our string, so that'd be a 3. So here we go, we have a 3, and what we want to do is look up our character. So we have D, E, F. So then our next one will be D, and then we call it again, comes up here. Index is now 3, which is indexes is now 2, which is greater than or equal to the digits length. So what we do is join these up to A, D, and then here our new element is pushed, and then we return. And then what we also need to do is remove the element that we added in order to go through them. So then we say stack dot pop, and then we start over. So then our new stack is gone, but we're still in the same characters of 3. So our next one is E. So then we push E, and we go through. It is greater than or equal to, so then we go to AE. And then we remove E, we pop it off, and then we go through, and we get F. And then our index is greater than or equal to the digits length, so we push it to here. So here we got AF. Good, and then we're done, and then, we now have jumped back to our first one. So this has gone here. We've gone through all variations of A. And then here, we're now on to the second character, which is B, and then we go through the same thing again. Then we add D, and then we add BD, and then this is gone, and then now it's E, and then we add BE, then we add F, then we add BF, and then we move on to C. So this would be CD, etc. So I hope you understood what I was talking about. I'll go more in depth into this when I do a more deeper dive into recursion and backtracking in a series, but this is how you do it if you're familiar with backtracking or recursion. This is a pretty straightforward way of doing it. Now let's go ahead, run it, and let's make sure it works. I hope it works. What do we get? Please work. Error. Okay. Digits at I, you're right, it is index. Let's see. So index is 0. Okay, good. Let's run it again. Please work. And we do pass. Here we go. Case 1. Good. And we're going to go ahead and submit it against the larger test suite. And we pass everything. Great. Runtime, not so good. Memory, not so good. But you're going to run into that with recursion. So, who knows? Pretty straightforward. Yeah. Fun stuff. So, yeah, that is our 2 questions for today. So, let's see here. When we do recursion, our time complexity would be the number of branches to the power of n. So not really a great time, or not really a great time complexity, but it's okay. And then our space complexity would be O of n, because we need to go down to the very bottom of our stack, which would be the same length of our digits. So O of n, where n is the length of our digits, that would be our space complexity, to hold on to that. Also, O of n, where we keep track of the numbers. So pretty straightforward. If you have any questions, please post them below. I'll try and help you out to the best of my ability. I hope you gained some knowledge from this. I hope you understood the way I think, the way I tackle this question. And the main thing with, preparing for interviews is just being able to spot patterns. The way I spotted that this is probably going to be recursion or backtracking. Recursion/backtracking. And yeah, just got to get your reps in. You don't get good at something unless you do it. So just go out there, try your best. If you get stuck, look for some help, and then move on to the next question. Anyways, hope you had a great day. Thank you for watching this. I'll talk to you later.